Okay. So, the last two lessons ago, we looked at translations where we were moving graphs left and right, up and down. And then last lesson, which was the end of last week, we did dilations, okay, which was stretching the graphs vertically and horizontally. And as I warned you, today we are going to be combining. It says a combination of transformations in there. So the table, we've already talked about these things that are in here, but it's a little bit of a reminder. If you want to shift something horizontally to the right, then you're going to replace the x with x minus h, h being the number of places to the right that you want to move it. If you wanted to move it to the left h places, it would become an x plus h. Okay, and you would sub that into your function. So this is what the f of x minus h means. It means everywhere where there's an x, you're replacing it with that x minus h. If you want to shift a graph vertically upwards, you're going to replace the y with y minus k. Often our equations are in y equals form, so that would be on the left-hand side of the equation, and then we usually just move that number across the other side anyway, and it will end up as our original function with a plus k on the other side when we move it across. If we want to stretch something horizontally, horizontally being the x-axis, if it's a factor of a that I want to stretch it, then I want to do x over a. That's Marvin the math spider, the year 7s, we've named him. Okay? No, we're not allowed to kill him. And you sub x over a into the function like that. It's just a little spider. He's not going to hurt you. If you're going to stretch horizontally, I should say, that says horizontal, that should say vertically. I've got to change that word. If I want to stretch it vertically by a factor b, I want to replace the y with y over b, and because that's normally on the left-hand side of the equation, we're going to times the b across to the other side, and it would be in front of our original function. Okay, here's a new word for you. We shall see that it sometimes matters in which the order the two transformations are applied. So I told you we're going to be doing two things in these questions. So sometimes it does matter the order. Two transformations are said to commute if the order in which they applied does not matter. Okay, so it doesn't matter which one you do first, you'd end up with the same result, and that means they commute. So graphs or translations, dilations that do commute, there's a list of the types that commute here. Any two translations commute, okay? Any two dilations are going to commute, including reflections. And a translation and a dilation commute if one is vertical and the other is horizontal. Perhaps it is easier to remember the ones that do not commute. So the ones that do not commute, which means they do not give you the same result if you do them in a different order, is if you do a vertical translation and a vertical dilation. So both in the vertical direction, a translation and dilation, you would not get the same result if you switched the order that you did them in. And a horizontal translation and a horizontal dilation do not commute. So if you remember that those are the two types, so horizontal translation and dilation and a vertical translation and dilation, they are the only ones that do not commute. Everything else should. Okay? All right. A universal formula involving all four transformations. So this is trying to put all of our different things together into one rule. The following sequence of transformations transforms the function of y equals f of x, there's our original function, to y equals k outside of f of a bracket a plus b plus c on the end. That is all four types of translations all in one equation. So number one, the 1 over a, which is normally to stretch something horizontally, timesing that into, or putting that into our bracket. It's the first thing in the bracket there. So we're stretching that horizontally by 1 over a. The b in the bracket next to the a means that we're shifting it left because it's a positive b, shifting it left b places. The k out the front of the function, that's normally one that we've times across from the y side. That means we're stretching it vertically by a factor of k. And the c on the end, I think, is the easy one, where we're moving our graph up or down c places. Up if it's positive c. Okay, so it's putting it all together. It does say there, alternatively, the vertical dilation and translation, so step 3 and then 4, could be done before the horizontal dilation of steps 1 and 2. So you could switch the order around and it would still work. Okay, let's have a look at what you're going to have to do. Example number 1. Compare shifting y equals x squared, right 4 and then down 2, to moving it down 2 and then right 4. Are the results the same? Do the translations commute? Now you could probably answer that already based on all the information I've just told you, but we've been asked to show it, right? So we're going to do each of those things. So let's divide our page in half here. The first one we need to do, we're starting with y equals x squared, and we're asked to shift to the right 4 spaces. Okay, that means if we're going to do this algebraically, I'm going to replace, you guys should tell me, what am I replacing? Yes, it is the x-axis, and because we're going to the right, it's going to be x minus 4. So I should have a with in between there. So we're replacing the x with x minus 4. So that means my equation is going to become, instead of y equals x squared, I'm replacing the x with x minus 4. So it's x minus 4 squared. There's my first move. The second move on that same equation is to then move it down 2 places. So to move down 2, what am I going to replace this time? Y? Yeah, good. So y plus 2, because moving down opposite is to do plus 2. So that means the y becomes a y plus 2 equals x minus 4 in bracket square. We're doing this from the equation that we just made. And then we're going to subtract the 2 across to the other side. So we have x minus 4 in bracket squared minus 2. Okay, so that was doing it in the first order that I was given. Let's now reverse the order and see if we get the same thing. So reversing the order, starting from the y equals x squared graph again, means that we're going to move down 2 first. So we're going to replace the y with y plus 2 as the first step. So that's going to be y plus 2 equals the x squared, and subtract the 2 across to the other side. So x squared minus 2. Then I want to move it to the right 4 places, which means I'm now going to replace the x with x minus 4. So subbing that in, it will be y equals x minus 4 in bracket squared minus 2. And that is the exact same equation as what I had when I did it the first way. So that is an example of showing that those 2 translations, they are both translations, a horizontal and a vertical translation, they do commute. So let's do it. Therefore, yes, they commute. Question 2. We're only doing 2 questions. Should be a nice quick one today. Question 2, we're now considering a circle The circle has the equation x plus 3 in brackets squared plus y squared is equal to 1. So it tells me the steps that it wants me to do. It wants me to apply a reflection in the y-axis, which means a horizontal dilation with a factor of -1. Then we're going to apply a translation of left 2 units, and we're going to find the resulting equation and we're going to sketch it. Okay, let's do that. So the first step was to apply a reflection. If I'm doing a reflection on the y-axis, it means I'm going to replace what? No, if it's a reflection on the y-axis, it's an x with, what was it? It does involve a -1. This is a dilation. So you could, we usually write it like that. So if this is a dilation, which means you divide by your dilation factor. Okay? Sub that into your equation. So everywhere where there's an x, that x plus 3 is going to be x over -1 plus 3 in brackets squared plus y squared is equal to 1. Now that negative in there, we want to be able to bring that out so that we can read off the center of our circle. So if I bring out the -1 as a factor, I have to square it because that bracket is squared, and it's just going to become a +1, isn't it? Bringing the negative out of the x, though, means that that's going to become positive, and bringing the negative out of the 3 means that needs to switch signs to be a -3 in there. Okay, then plus y squared equals 0, so I can just get rid of that -1 squared out the front. So it's x minus 3 squared plus y squared equals 1. So I've done my horizontal dilation of -1. The next step, then apply a translation of left 2 units. So I have to replace what this time? X with, you're right, it's x. What am I replacing it with?
X positive.
X plus 2, yes. Okay, because we're going to the left, it means I need a +2, and I put that into my equation. So it's x plus 2, and then there's still the -3 in there in brackets squared. Plus y squared equals 1. Now the +2 minus 3 makes x take away 1 in brackets squared plus y squared is equal to 1. Okay, so we have done the 2 different moves that we've been asked to do. Now I want to draw that. It is a circle. What is the center? 1, 0, and the radius is equal to 1. All right, so let's draw a quick sketch over here. So 1, 0 will be there. That's my center. And I need a radius of 1 going the whole way around that. So up 1, down 1, left, right 1, and a lovely little circle. Now part B is going to be to apply those steps in the opposite order. We have our same equation of a circle again, but this time it says to apply the translation of left 2 units first. So, reversing the steps, we're going to replace the x with x plus 2 into my equation. That's going to make x plus 2 plus the 3 in brackets squared plus y squared equals 1. Adding together the numbers in that bracket would become x plus 5. Bracket squared plus the y squared equals 1. Second step says, then apply a reflection in the y-axis, which is our horizontal dilation with a factor of -1, which means I want to replace the x with x over -1 or -x, which would be x over -1 plus 5 in brackets squared plus y squared equals 1. And like usual, bring the minus out of the bracket. So bringing the minus 1 out, when I square it, will become positive. So can I just leave that bit off this time? And that means that the x will become positive, the 5 will become negative, squared plus y squared equals 1. Clearly, you can see that that is not the same equation as the one that I got in part A. What is the center of that circle? 5, 0, but the radius is still 1. Okay, so that leads us to part C, but I better draw it first. 1, 2, 3, 4, 5, 6. So 5 is the center. Up 1, down 1, left, right. Oops, that was not a good circle. Start that again. There's my circle. So you just show where they intersect, and that's enough. So part C says, do the transformations commute? No. And we knew that from the beginning if we thought it through, because they were a dilation and a translation in the same direction. They were both on the x-axis, which was one of our criteria that we knew was not going to work. Okay, so we just need a big fat no in there. They did not commute. All right, so that's 3I.